Hello, geometry. Let's give this a try. This is week 2 of online learning, and this is the first assignment, so this is assignment 2.1. And technically what we're going to do, I decided that we're going to do one last week of similarity, and then we're going to move on. So this is kind of finishing up chapter 12, if you remember, and we're going to look at some shortcuts to show that triangles are similar, because we love triangles. Love triangles. So we had some shortcuts. You remember side, angle, side. Side, angle, side, angle. Side, angle, side, 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 side. You remember that song? There was a whole bunch of shortcuts that we could prove that triangles were congruent. Now we're going to look at 3 specifically that are going to prove that triangles are similar. This first one is angle, angle, triangle similarity. So if 2 angles of one triangle are congruent to 2 angles in another triangle, and in my picture, because I've got a picture that goes with all these, I see that this angle A is congruent to angle D, and that angle E is congruent to angle E. I've got 2 angles that are congruent in one triangle and another triangle. Then the 2 triangles have to be similar. So basically, my little shortcut here is if you have 2 congruent angles between your triangles, maybe not necessarily the same side lengths, but your side lengths are in a common proportion, then your triangles would be similar, all right? And again, common proportion, sides not always the same. We do see that triangle ABC here. Oops. Triangle ABC is much bigger than triangle DEF. All right, so that's angle-angle similarity. If you've got 2 angles that are congruent, then you can say that you have similar triangles. So let's look at an example of this real quick. I encourage you to hit pause and read the whole thing because I'm just going to get started here. We're asking, what is this length of PQ? So this length right here, I'm just going to call that X so we know what we're solving for. This triangle, or not triangle, camera is moving along some parallel lines here. These dot guys right here that I'm dashing. And what I've done is I've taken this entire figure and I have sketched it off to the side, all right? So we're looking at these like 2 triangles here, and we're asking what's the length of this third side. So I'm just going to move it over to my sketch. It's a lot cleaner to look at. First, we have to figure out, can we possibly use angle-angle triangle similarity here? Well, I see that I have 2 lines that are intersecting right here. That means that they form vertical angles. So our opposite angles here, these vertical angles, they have to be congruent. That's one pair of angles that are congruent between these 2 triangles. If I can find a second pair of angles that are congruent, then I can show that these are similar, and I could set up some common proportions and solve for this length of X. Well, and I do see again that these lines are parallel, probably going to have some alternate interior angles in here. Yes, you will. So this angle and this angle over here, they are alternate interior angles. And we could go along and say, hey, I've got these other angles right here, and you've got a whole bunch of angles that are congruent. But we're really just fine with showing at least 2, right? So just from here, we have enough information to show that these triangles are similar. Let's set up a proportion between these 2 triangles and see if we can solve for this third length X. So off to the side, I'm going to say, well, I know that this side, this side 4 is the like corresponding side to X, right? So there's this proportion 4 over X. The ratio between 4 and X has to be the same ratio between my side 15 and 21. Notice how I'm going from this triangle here to this triangle. So I'm saying 4 over X, and then I'm going to say 15 over 21. So I have this ratio of 15 over 21. Again, if we have similar triangles, that means that these proportions have to be the same. That's why I can set this ratio of 4 to X equal to 15 to 21. Now we can just cross multiply and solve for X. So I'm going to cross multiply here. I have 15X equals, and then 4 times 21 is going to give you 84. Divide by 15 on both sides to solve for X, and I'm going to get that X equals 5.6. There's our missing side length of 5.6. Rock on. All right, so noticing some corresponding sides in our triangles that would be similar, setting up some proportions, being able to solve for a missing value here. Okay, I'm going to move on to the last two that we're going to talk about real quick. So we just talked about angle, angle. If you've got two angles, then you're good to go to say that they're similar. Now we're going to look at side, side, side. So here, again, we're not talking about congruent sides. The sides aren't going to be the same length, but as long as you have three sides of one triangle being proportional to the other three corresponding sides of another triangle, then your triangles would be similar. All right, so in my little shortcut here, I have if three sides are proportional, then your triangles are similar. In these two triangles, I can check to see if all of these sides are in a common proportion and see if I can use side, side, side here. So I'm going to set up these proportions off to the side. I'm going to look at 15. Its corresponding side length over here is going to be 10. This 12 and 8, so 12 over 8. Again, I'm kind of going from this triangle over to this triangle, right? So I'm keeping these ratios consistent. And then this 18 over 12. 18 over 12. And if you see, all of these are going to simplify down. These are all the same proportion. They're all 1.5. So really what I'm doing is I'm taking the scale factor of 1.5 to multiply here to all of these sides. Therefore, they have to be similar triangles, all right? So if you can show that all of the sides in our triangle are proportional, then you are good to go, all right? So side, side, side. Side, angle, side. Side, angle, side. Here we go. So here, if you have two sides of one triangle being proportional, and I'm going to look at these and I'm going to say I've got this AB and this FD. Whoops. Those two are proportional sides. And then I also have this 24 and this 16. How do I know exactly that those corresponding sides are corresponding to each other? Well, if I look at it, here's this 12 and this 24. The 12 is the smaller side in the triangle. And in this triangle, the 8 and the 16, the 8 is the smaller side. So I'm probably going to guess that 12 and 8 are going to be my corresponding sides in these triangles. All right, what do I got? If I've got two sides of one triangle that are proportional, which we do have in here, right? Again, we're kind of using the same scale factor that I used before. If I can multiply this 8 by a scale factor of 1.5, if I can multiply this 16 by a scale factor of 1.5, they're the same scale factor. These sides have to be in a common proportion. All right, so that takes care of that part. And if their included angles are congruent, all right? So if you have two sides that are in common proportion, and if the included angle between those two sides are congruent, then you would have similar triangles. And in this case, hey, oh my gosh, we do have congruent included angles. So these two triangles would be similar using the SAS triangle similarity theorem. Alrighty, let's do an example. All right, so we just covered side, 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 and we just covered side, angle, side, triangle similarity theorems. I'm going to have this little picture here. I'm going to ask you, see if you can find the value of x. But first, before we find the value of x, we have to determine if these two triangles are similar, all right? So we're probably going to be using one of these two here, side, 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 or side, angle, side. Just from looking at the picture, can I use side, side, side? I have, let me get a color. I have a side, I have a side, I have a side. I have a side, I have a side. I don't have a side, that's what we're trying to find. So I'm probably not going to be able to use SSS here. Will I be able to use side, angle, side? Well, I'm given this angle of 24 and 24 here, so that's an included angle. Yes, I have same included angles. Are the sides going to be proportional that make up these included angles here? What I'm going to do is I'm going to look at this triangle ABC. I have my bigger side of 12 and my smaller side of 10. Hang on, I'm going to color coordinate this. So I've got my small side of 10, which I'm going to put in orange, and I have the bigger side of 12, which I'm going to put in green. Over my triangle DEF, I have the bigger side of 15.6 and this other side of 13, which would be the smaller one. If we're just looking at the sides that make up these included angles, right? Because I got to determine if these are in a common proportion. Let's set up proportions between these two sides. And I'm going to go from the big triangle to the little triangle. So I'm going to say that 13 over 10, my smaller side to my smaller side, this ratio has to be equal to the ratio from my bigger side to my big side here, right? So 15.6 over 12. And are those ratios equal? Well, I just plugged in my calculator. I did 13 divided by 10, and that got me this kind of scale factor of 1.3. And then in my calculator again, I did 15.6 divided by 12, and yes, I got a scale factor of 1.3 again. So yes, these two sides are in a common proportion. My included angle is congruent. Therefore, now we can say that these two triangles are going to be similar. So now I just got to find the value of x, right? And that third side we know has to be corresponding to this 6.5 side. So now I'm going to set up this ratio of 6.5 over x, all right? Let me get rid of some of this stuff here. So I just did 6.5 over x has to be equal to the same ratio. I'm just going to pick the 13 and the 10. So the 6.5 to the x has to be the same ratio as 13 to 10, equal to 13 over 10. And now I can just solve for x, right? What do I got? Cross multiplying, that's going to be 13x equals 65. Divide by 13, and x equals 5. Wonderful, wonderful. Please let me know if you have any questions. All right, I am going to assign 4 questions today. Not too bad, not too bad, all righty? Have a great day, and I will hasta la vista. See you later. Go team. What up, everybody? I want to talk through this assignment real quick, just so you know what we're doing. This is the assignment. It's only 4 numbers or 4 problems that go with the lesson that you just watched. You can either use this Word document or, copy and paste it into your own Word document, or if you want to do it on your own separate sheet of paper, it is the problems right out of the book on page 380, number 3, 5, 15, and 18. Number 3, it asks, are the triangles below similar? If so, what is the value of x? You're probably going to have to use one of the triangle similarity theorems that we just talked about in the lesson to show that they're similar. And then be able to set up a ratio between these two triangles with their side lengths to solve for that value of x. And hint, hint, it's probably not going to be the angle, right? Because you're only given information. You only know one of your angles. And I know that that's a right angle, but I don't know anything else about the other angles. So you're probably not going to use triangle similarity to show that those are congruent. Or I'm sorry, to show that they're similar. Yeah, so oh my gosh. Ooh, what theorem are you using and what is the value of x? Here are the two triangular flags similar. Explain or show some work. Remember in the lesson that we had 2 triangles, we had a whole bunch of sides, right? These 2 triangles would be similar if all 3 of the corresponding sides are going to be in a common proportion. So is this proportion of 9 to 4.8 the same proportion as 10 to 5 and 4.8 to 2? All right, set up some proportions, see if they're all the same. Find the value of x that makes a triangle PQR similar to triangle TUV. Do you think you could possibly tell me some information about all of the angles and similar figures? Would they be congruent or not? Maybe you could set up an equation thinking about all the angles in a triangle. This one, it looks like a lot. Do not freak out though, all right? If you read the question, it's really asking you how far or how wide is the river. So it's really asking, what's the length of segment AB, all right? You are given enough information in that figure. You can set up some ratios. Try and see how far the river is, how wide the river is. All right, go team. Also, thank you so much for all of your hard work last week. You guys did great. I know it's all new and it's all unexpected. But you guys did great and I really appreciate it. Go team!